So today we'll be focusing on Python libraries, especially SciPy, Scikit-learn, PyBrain and Pylearn2. So we know the importance of Python and the libraries associated. So we'll start with the first library called as SciPy. SciPy stands for Scientific Python. So it's an open source Python library. It is used for scientific and technical computing. It is built on NumPy and it provides models for optimization, integration, interpolation, eigenvalue problems, algebraic equations and others. What are the key features of SciPy? Numerical integration, SciPy.integrate, optimization, SciPy.optimize, signal processing, SciPy.signal, sparse matrix operations, statistic analysis, SciPy.stats. So for SciPy, a small case study is mentioned here, which is used for signal denoising. So there is an ECG signal which is corrupted by noise, and that needs to be denoised. So you can see here we are importing NumPy, and then we are importing signal from SciPy, then we are importing matplotlib pyplot. We are simulating the noisy ECG signal with this line of code. And then we are applying a Butterworth filter to denoise it. This is the code for that. And the signal which is filtered will be given. You can see the plot results being mentioned as this is the noisy ECG. This is the filtered ECG with legend, signal denoising with SciPy. So the second library in Python being mentioned here is Scikit-learn. Okay, so it's a simple and efficient tool for predictive data analytics. So mostly machine learning problems are solved here. What are the key features of Scikit are? Used for supervised and unsupervised learning, for model selection evaluation, for pre-processing and feature extraction, for pipelines for reproducible workflows. You can see here a typical case study for Scikit-learn, diabetes prediction. So the data set being taken from UCI, and we need to predict whether the patient has diabetics or not. So typical code content maybe will be importing the data set from Scikit-learn. Then we'll be importing linear regression model from Scikit-learn. Then we'll be dividing our data set into train and test, and we'll be using the mean square error metrics for performance. So you can see here data set is loaded, and we are labeling them. Then we are dividing them into train and test. Then we are training the linear regression model. Then we are predicting the value and evaluating its performance through MSE. The next library from Python is PyBrain. It is used for reinforcement learning, AI and neural networks. It is not that actively maintained nowadays. The key features are neural networks, feed-forward and recurrent, reinforcement learning, value-based and policy-based, evolutionary strategies. Here there is a case study being mentioned that neural network needs to be trained to learn XOR table basically. So we'll be importing supervised data set from PyBrain. We'll be importing build network from PyBrain tools. Then we'll be importing the back propagation trainer from PyBrain again. So data set we are defining here by adding the samples. Then we are building the network and training it with back propagation trainer. So then the predictions are being done. The next Python library is Pylearn2. It is used for deep learning research. It is built on top of Theano. So people who want to experiment with novel architectures, training algorithm, they can use Pylearn2. It is also not so active nowadays, but its significance and importance is there. It supports CNN, RBM's autoencoders. Here a case study is mentioned for image classification using CNN. So you can see here YAML configurations are there and integration with Theano is there. So problem given is you are going to classify the digits from the data set using CNN. So what we'll be doing is we'll be loading the data set, pre-processing it. We'll be defining the model architecture in YAML. We'll be training the model using SDG, and then we'll be evaluating the classification accuracy. You can see here, this is the YAML snippet, so for training. And we are taking the dataset MNSIT, and we are using one-hot encoding. Then we'll be using the model NLP, and you can see here convolution rectified linear is being applied. So all the parameters like kernel shape, pool shape, output channels are mentioned. Softmax is being applied, and ultimately we'll be training the SDG. Okay, so this was a small snippet, and we basically covered these libraries from Python called as SciPy, Scikit-learn, PyBrain, Pylearn2. And as we can see, SciPy is used for scientific computing, mathematics, signal processing. The strengths are numerical tools, integration, statistics. Scikit-learn is used for classical machine learning. The strengths are simplicity, robust API pipelines. PyBrain is used for RL and neural networks. Strength is for NN and RL. Pylearn2 is for deep learning, symbolic computation and flexibility. Now we also know that there are other frameworks like TensorFlow, PyTorch and Keras which have become more popular. Okay, that's all for now. Thank you.